Welcome guys, welcome to my channel Marine Sea Time. Today I will discuss about MARPOL annex 6, that is regulation for the prevention of air pollution from ships. It applies to all ships. Total number of regulation is 19 and we have 3 chapters and 2 appendix. Chapter 1 is general, chapter 2 is survey certificate and means of control, chapter 3 is requirement for control of emission from ships. So we'll discuss all these 3 chapters and 2 appendixes also. In chapter 1 you will get application, definition, general, exception, equivalent. Chapter 2 survey certificate and means of control. Survey and inspection, issue of international air pollution prevention certificate, issue of certificate by another government, form of government, duration and validity of certificate, PSC on operational requirement, detection of violation and enforcement. Chapter 3 is important, requirement for control of emission from ships, ozone depletion substance, for NOx, 14 is SOx, 15 is volatile organic compound, 16 is shipboard incineration, 17 is reception facilities, 18 is fuel oil quality, and 19 is requirement for platform and drilling rigs. So let's start with chapter 1. And we have 2 appendixes, regulation on energy efficiency for ships, and appendix 2 is verification of compliances. So now we will deal with chapter number 1, which is general. Now chapter number 2. Chapter number 1 generally talks about definition and all that. In chapter number 2 we will discuss about survey certificate and means of control, that is regulation number 5. Regulation number 1 to 4 is in chapter number 1. Regulation 5, survey and inspection. Every ship of 400 GT or above and every fixed and floating drill rig and other platforms shall be subject to survey specified below. So every ship of 400 GT and above will have to be subject to the survey specified below. An initial survey, before initial survey is done before a ship is put into service. This survey shall be such as to ensure that the equipment, system, fitting, arrangement and material fully comply with the applicable requirement of this annex. After a new ship, we do initial survey, we do periodical survey. Periodical survey at an interval specified by the administration but not exceeding 5 years. Same survey as above, fitting, equipment, etc. A minimum of 1 intermediate survey during the period of validity. So in this we will do an intermediate survey and a periodical survey. That means at 2.5 years, and if the certificate is valid for 5 years, so we will do an intermediate survey, that is 2.5 years, and a periodical survey, that is at an interval of 5 years. No annual survey is done here. That is in 5 years we will do an in the middle and at the end. Regulation number 6, issue of IAPP certificate, engine IAPPC and international engine efficiency certificate. So we have 3 certificates: IAPP International Air Pollution Prevention Certificate, Engine International Air Pollution Prevention Certificate, and International Engine Efficiency Certificate. So we have 3 certificates. The form of certificate is IAPP, EIAPP, IEEC. So regulation number 7, issue of certificate by another government. Regulation number 8 is form of certificate. Regulation number 9 is duration and validity of a certificate. IAPP for 5 years with renewal, annual and intermediate survey. So for we also do annual survey also. So for IAPP for 5 years we do on first year, 2.5 years, and then at 5 years. So renewal means 5 years, annual means 1 year, intermediate means 2.5 years plus minus 3 months, second and third anniversary date with plus minus 3 months. Regulation number 10 is PSC operational requirement can detain a ship if not followed. Regulation number 11 is detention of violation and enforcement. So we have completed the chapter number 2. We have completed the chapter number 2, which was survey certificate and means of control. Now we will go to chapter number 3, requirement for the control of emission from ships. Requirement for control of emission from the ship. So we'll discuss about ozone depletion substance, regulation number 12, 13 is for NOx, 14 is for SOx, 15 is for volatile organic compound, 16 is for shipboard incineration, 17 reception facilities, 18 fuel oil quality, 19 requirement for platform and drilling rigs. So we'll first discuss about regulation number 12, ozone depletion substance. This regulation does not apply to permanently sealed equipment where there is no refrigerant charging connection or potentially removable component. So it does not apply to any system, any equipment which doesn't have any refrigerant charging connection. Deliberate emission of ozone depletion substance shall be prohibited. Deliberate emission include emission occurring in the course of maintaining, servicing, repairing, or disposing of system, or except that deliberate emission do not include minimal release. So during maintenance of any refrigeration system, or during servicing or repairing, or any gas filling in the system, so deliberate emission of ozone depletion substance is prohibited, totally prohibited. On ships constructed after 2005, no ozone substance to be used, only HC hydrochlorofluorocarbon is used. So no ozone substance to be used, only HC. After 2005 it was there that only hydrochlorofluorocarbon will be used. Now the latest regulation is that on ship constructed after 2020, HCFC is also prohibited. So there will be only HFC, hydrofluorocarbon. Okay. Any refrigerant containing chlorine is prohibited. Before that it was hydrochlorocarbon. Then we had HCFC, hydrochlorofluorocarbon. If there is fluoro, then it is good. If it is chloro, then we do not have to use that one. So after 2020, the regulation says that HCFC is to be prohibited. Every ship shall maintain list of equipment containing ozone depletion substance. Shall maintain a ozone depletion substance record book if system contains ozone depletion substance. Now regulation number 13. We have talked about ozone depletion substance. Now regulation number NOx, applicable for only main engine and auxiliary engine, because NOx is only found in main engine and auxiliary engine, because it needs a high temperature to form NOx. The regulation shall apply to each diesel engine with a power output of more than 130 kW which is installed on a ship constructed on or after 2000. This regulation does not apply to emergency diesel engine. Emergency diesel engine installed in lifeboat, and any device and equipment intended to be used solely in case of emergency. So in case of emergency, we use emergency diesel engine, and also lifeboat, rescue boat. So this regulation, so NOx regulation does not apply to any of this. How this NOx is found? NOx is found by the nitrogen and oxygen in the marine fuel in IC engine during the combustion chamber. But the correct mixture of fuel and air is present of the heat or ignition source. When nitrogen and oxygen under certain engine operating condition to form NOx. So at 1000 degrees Celsius, nitrogen and oxygen combines at a nitrogen and oxygen combines at 1000 degrees Celsius to form NOx. So cause of NOx in marine engine, resilience time. So how much time it stay in combustion chamber? So high speed engine has low resilience time, so less NOx. So high speed engine will have low resilience time, that means there will be no time for nitrogen and oxygen to combine. So in slow speed engine, nitrogen and oxygen, slow speed engine, it takes more time for combustion. So nitrogen and oxygen easily can combine and can form NOx. So resilient time is important. So slow speed engine has low resilience time, so NOx formation will be there. High cylinder temperature and pressure during combustion process. Heavy load on engine or engine out unit. Improper air and fuel ratio for combustion. High temperature of intake or scavenge air inside the cylinder. Overheated cylinder jacket due to poor heat surface by jacket cooler. So if the temperature is high for any reason, the cylinder jacket is not working properly for any reason, if the temperature of the combustion space is high, then it can lead to formation of NOx in marine engine. Now we will check what is the latest requirement to be kept on for NOx emission. So if you can see, the engine is divided into tier 1, tier 2, tier 3. In my ship it was of tier 2. So here you can see n is less than 130, n is less than 130, n is between 130 and 2000, n is greater than 2000. So generally in SIP we have n is less than 130 rpm. So tier 1 SIPs should have to maintain the NOx emission to 17 gram per kilowatt hour. For tier 2 SIPs of less than 130 rpm should maintain 14.36 gram per kilowatt hour. So in my SIP we have to maintain this 14.36 gram per kilowatt hour, and for tier 3 SIPs 3.4 gram per kilowatt hour from 2016 onwards. From 2016 onwards, the latest regulation says that you have to maintain 3.4 gram per kilowatt hour. After 2016, my SIPs was built in 2012, so we had tier 2 type of vessel, so we have to maintain 14.36 gram per kilowatt hour. For vessels built after 2016, they have to maintain 3.4 gram per kilowatt hour, and this is the latest regulation. And for engine, for auxiliary engine, speed lies here, which is of 900 revolution or 1200 revolution. So this is the latest revolution. 9 into n to the power minus 0.23. 9 into n is the speed of the generator to the power minus 0.23. And if the speed is greater than 2000, which we generally don't use, so this is the auxiliary engine, main engine. So this two we have to actually learn. 3.4 and 9 into n to the power minus 0.23. So now I will tell you how to reduce this NOx emission in engine. First one is humid air motor. So you can see that air is supplied from here, water is injected into the air system, and saturated air goes into the cylinder. So this is how the humid air motor works. The scavenge air is passed through in scavenge air, the water is injected into it, and from here saturated air goes into the cylinder. So as water has high specific heat capacity, so it will take the heat of the cylinder and it will reduce the temperature of the combustion chamber. So it reduces NOx by 70%, dilution of charged air by water pressure. It has several disadvantages such as large space requirement, high investment, SFOC, specific fuel consumption slightly high, slight increase in smoke discharge. So this steps humid air motor, this all disadvantage we have. Now second one is exhaust gas recirculation. So basically we want to reduce the oxygen content of the air so that the nitrogen and oxygen will not combine, because that is if we reduce the oxygen content in the air, then obviously NOx required oxygen also. So basically we are reducing the oxygen content by exhaust gas recirculation. 15% normally exhaust gas is recirculated with the scavenge air. So by reducing the oxygen content in the scavenge air, we can reduce the NOx emission. So exhaust gas recirculation, number 2 steps. Number third is direct water injection. H2O is directly injected into the combustion chamber. So it will cool the combustion space. So in order for the NOx to form, we need nitrogen, oxygen, and the combustion space temperature should be above 1000 degrees Celsius. So by injecting water, we are reducing the combustion space temperature. So NOx will be reduced automatically. Reduce NOx by 50 to 60%. Water injection timing and during is computer control. Water injection timing is computer controlled as a specific fuel consumption increases and NOx reduction to 20 to 45%. Now fourth step is high scavenge pressure and compression ratio. With this, large amount of air can be introduced inside the cylinder to lower combustion temperature. Fifth one is by selective catalytic reduction. In this, it reduces the NOx by 90 to 95%. So here you can see the ammonia solution tank. This is SCR reactor. Here NOx is sensed, NOx sensor, which will sense. This is the exhaust gas inlet, and this is the exhaust gas inlet and exhaust gas outlet. So you can see here we have a control unit over here. Control unit, ammonia solution tank. So the control unit will sense the NOx content in the outlet of the exhaust gas. It will sense the NOx emission and it will give to the control unit. The control unit will automatically switch on the pump. This is the pump. It will switch on the pump and will make the ammonia solution to go and react with the exhaust gas. Okay, so the control unit will sense the NOx from the exhaust gas outlet and it will give it to the pump. The pump will accordingly switch on and off, and it will pump the ammonia solution from the tank to the mixing unit. So exhaust gas plus ammonia, 40% urea solution in water. Ammonia is basically 40% urea solution in water, passed through a special catalyst in a temperature between 290 and 450 degrees Celsius. So you can see here is a SCR reactor. SCR reactor, which is a special catalyst, V2O5 vanadium pentoxide. This is a honeycomb chamber. So at a temperature of 290 to 450 degrees Celsius, so NO plus NH3 plus O2 gives water and nitrogen. So nitrous oxide react with ammonia to give water and nitrogen. So here you can see the NOx reacts with ammonia to form water and nitrogen. So by this the NOx emission can be reduced. A low sulfur fuel is used. If we use SCR, a low sulfur fuel is generally used in the engine because at low temperature below 290 degrees Celsius, ammonia and sulfur dioxide react to form ammonium sulfate. We do not use this system because high cost of installation. Number 6 step is two-stage turbocharger. Two intercooler we use to decrease the temperature of the charged air. Engine component modification. So this is the best method, engine component modification, which we generally use in SIP. We generally don't use SCR, radiator motor and all that. We generally use engine component modification. We usually modify the component. It is better to design an engine which has a property to reduce the NOx formation during combustion process rather than investing in expensive secondary measures. Integrating of slide valve. We generally use a slide valve type of fuel injector with almost zero sac volume, eliminate fuel dripping and afterburning. So this type of fuel injector slide valve type, which is generally used on ships, this eliminate the fuel dripping and afterburning in the engine. And we have to maintain, the basic method is to maintain all parameters regularly. This is the best method adopted to reduce the NOx emission. So we are maintaining all the parameter, temperature, pressure in the engine to a correct value so that NOx emission can be reduced. We have a NOx technical file. Above 130 kilowatt engine is to have one NOx technical file. So those engine which has come under annex6 installed after 2000 power output greater than 130 kilowatt to be tested and issued with an engine international air pollution certificate and approved NOx technical file. The approved file provides detail. The approved file provides detail of allowable engine component setting, operating value and allowable adjustment, which ensure the engine will operate within the acceptable NOx emission limits. So the NOx technical file will give some parameters that yes, you have to maintain 350 degrees Celsius only at at 350 degrees Celsius exhaust gas temperature. So we have to maintain approx on that temperature only. we have to maintain 2.5 bar scavenger pressure, so we have to maintain that scavenger pressure to that level only. If we are replacing any part and modifying any engine components, then we have to record this in the engine parameter. Number 6.1, adjust are made of FQS or VIT and operational region. The limit mentioned in the file should not exceed. So the limits are been given in the file that yes, you have to maintain between this and this, and we have to not cross this limit. We have to maintain and adjust the FQS or VIT. It's suppose we have to set FQS and fuel quality setting and variable injection timing. Then we have to set within this limit only. We should not exceed this limit. So what are the component list that setting that influence NOx emission? So these are all the components by which can influence the NOx emission. Fuel injection timing. So in the file you will be given about the fuel injection timing, what to keep, at what limit to keep, fuel pump, fuel cam, fuel injection nozzle modification, exhaust cam adjustment, cylinder cover liner replacement, governor setting changed. This is all about NOx. Now we'll go to SOx. Applicable for both engine, main engine, auxiliary engine, and boiler and incinerator, because SOx is formed by the sulfur content of the fuel, so it will be applicable all-where, incinerator, boiler. SOx is formed due to the bad quality of fuel. If the fuel quality has a high content of sulfur, then SOx will be formed. High percentage of sulfur in fuel during bunkering. Cause and effect: the SOx emission is due to the sulfur compound in the marine fuel used in the marine engine and on board vessel. Better the grade, lower will be the sulfur content as it is removed by refining the fuel. The smoke containing SOx emitted in combustion of marine fuel will further oxidize, and in the presence of catalyst like NOx will form H2SO4 acid, which is a major cause of acid rain. So this SOx, when react with water in the atmosphere, it can form acid rain. It has also been recognized the emission of SOx contribute in the formation of secondary inorganic aerosol gases, fine particles which are harmful to humans. It forms secondary inorganic aerosol gases, and these fine particles are harmful to humans. But due to MARPOL annex6 stringent norms, marine engines are now using better grade of marine fuel like marine gas oil. So with stringent rule, we are using many ships has adopted the use of marine gas oil or marine diesel oil. So heavy fuel oil is generally a low cost fuel, so we are using. But in near future, this heavy fuel oil can be replaced by this marine gas oil and marine diesel oil. Sorry. So what is the regulation for SOx? This is very important. You can see in the diagram. So 4.5%. After 2012, 3.5%, and after 2020, 0.5%. This is very important. After 2020, we will be using sulfur content in the fuel as 0.5%. Before that it was 3.5%. Okay. And for a special area, this is for a special area. Before 2010 it was 1.5%. After 2010 it was 1%, and now it is 0.1%. So now 0.1% in special area, percentage of sulfur m by m, and 0.5% sulfur outside the special area. So here you can see how to reduce the SOx emission. Use of low sulfur fuel oil. This is one choice, but the disadvantage is that it is expensive. Exhaust gas scrubber technology. Many ships today after 2020 are installing scrubber gas technology in their ships. This reduces the SOx by 95%. This is same that as of inert gas scrubber tower. So we have two for this. We have the automation system described here you can see in black color. The automation system during commissioning is optimized to the lowest possible energy consumption and keep the emission within stimulated limits, regardless of sulfur percent in fuel, engine load, or water alkalinity in fuel. So what this is that a scrubber system can operate in different mode loops: open, closed, and hybrid system. When the scrubber system works in closed system, an alkali such as NaOH is needed to clean the waste water that is held in wash water tank. So we have three type of scrubber system: open, closed, and hybrid. In open scrubber system, when the scrubber system works in closed loop, when the scrubber system works in closed loop, an alkali solution such as NaOH is added to the seawater in the waste water which we are adding in the scrubber tower. So NaOH is added, then only it is given into the scrubber tower, because we know in a scrubber seawater or waste water is needed so that the sulfur dioxide reacts with water to form sulfuric acid, and the sulfuric acid which is formed into the scrubber system, there is also some regulation in that I will speak after. So we have in closed water system, in closed loop system, we generally add alkali NaOH in the seawater, but in open loop system there is no need for water treatment as the natural alkalinity in the seawater neutralizes the acid. Okay, in open loop we do not add any alkalinity in the seawater because seawater has enough neutrality property to neutralize the acid, and the waste water which is formed after that is sulfuric acid. Sulfur dioxide reacts with water to form sulfuric acid, and it is below the waste product is sulfuric acid, and this sulfuric acid should be continuously monitored to make sure it is discharged into the sea with the no harm to the environment. So it is discharged into the sea so that it will not do any damage to the environment. So we have many sensors and all that which will check the discharge of this water into the sea. Other step is cylinder lubrication. Pulse or alpha lubrication can neutralize the sulfur in the fuel. NOx is not applicable for incinerator and boiler. Temperature and pressure requirement to make NOx are not achieved. The resilient time for the fuel to react with air is less in boiler or incinerator. The SOx is generally found in only NOx is not formed in incinerator or boiler because the resilience time is very less. So resilience time is very less. So NOx is not formed in boiler or incinerator, but SOx is formed in boiler and incinerator. Changeover of fuel oil entering into ECA area. All data to be included within written procedure. So I will number 15 regulation. So we have completed NOx, we have completed SOx. Now we will come to regulation number 15, volatile organic compounds. If the emission of volatile organic compounds from the tanker are to be regulated in a port or a terminal, the party regulating tanker for VOC emissions shall submit a notification to the organization. A tanker and gas carrier carrying crude oil shall have a VOC management plan approved by the administration. The plan shall contain at least written procedure for minimize VOC emission during the loading, sea passage, and discharge of cargo. Identify the person responsible for the plan. Now regulation number 16 is shipboard incineration. So what all things should not be incinerated into the shipboard shall be prohibited. Number 1 point is residue of cargo subject to annex 1, 2 and 3 or related contaminated packaging material. So anything which comes under annex 1 means all oil which I have told you in annex 1 MARPOL, annex 2 and annex 3, any cargo of annex 1, annex 2 and annex 3 are should not be burned in the incinerator. PCBs, polychlorinated biphenyl. This is actually what you can see in a capacitor or a transformer. The yellow like colors is basically a PCB. So polychlorinated biphenyl. So number C is garbage as defined in Annex 5. So garbage as defined in Annex 5. So the garbage should not be, these all garbages which contain more traces of heavy metals. Garbages which contain more traces of heavy metals should not be incinerated into the incinerator. Refined petroleum products containing halogen compounds, sewage sludge and sludge oil, either of which is not generated on board the ship. And the sewage sludge should not be incinerated. Exhaust gas cleaning system residue. So these are the things which should not be incinerated into the incinerator. PVC such as packaging shall be prohibited except in shipboard incinerator for which IMO type approved certificate has been issued. Regulation number 17 is reception facilities. Regulation number 18 is fuel oil availability and quantity. In fuel oil availability and quality, it is generally given at what bunker delivery, about the bunker delivery note. I will tell you in the last what is this bunker delivery note, what this regulation 18 tells about. So special area under this Annex 6 is for SOX, Baltic Sea area, North Sea area, United States Caribbean area, North America area. So these are the four you can see over here. Which one comes under SOX and which one comes under NOx. So for NOx, special area is North American area. Now we come under this chapter 4. Sorry, this is Appendix 1, Regulation on Energy Efficiency for ships. I have told that there are 3 chapters and 2 appendixes. So number 1 appendix is Regulation on Energy Efficiency for ships. So in terms of CO2 emission per ton of cargo, shipping is the most efficient form of commercial transport, but due to the sheer scale of industrial shipping contributes to about 3% of the world emission, which is a 0.9 billion ton in 2010. To top it all, popular studies indicate 75% increase in next 15 years due to the demand and growth in global trade. Needless to say, but IMO is getting pressure to restrict the pollution. So IMO regulation from ships so as to reduce the CO2 emission, be cost effective, and at the same time be based on sustainable development without restricting the trade and growth. So IMO is making several regulations to reduce the CO2 emission from ships without restricting the trade and growth of the shipping. So we have one formula, EEBD, Energy Efficiency Design Index, which is equal to power into specific fuel consumption into carbon conversion divided by capacity into speed. So the EEBD is basically the number of gram of CO2 emission per ton per nautical mile. So number of gram of CO2 emitted per ton of cargo per nautical mile. This is what EEBD formula tells. So we have to keep this EEBD very less because then we have to reduce the number of gram of CO2 emission. This essentially translates into number of gram of CO2 emission per ton of cargo per nautical mile. EBD conclusion. EBD is especially to measure the efficiency of ship in transportation, which has maximum cargo carried with minimum fuel consumption and minimize CO2 emission will give a vessel a good index. So as the CO2 is reduced, it will give a good EBD index. In near future, EBD can reduce their operational cost to reduce carbon emission. This is EEOI, Energy Efficient Operational Indicator. And the third one is Ship Energy Efficient Management Plan. So these are all the plans, the index which is given, you can read over here. Basically it is to reduce the carbon dioxide emission. So the carbon dioxide emission can be, this you can read from the formula, fuel consumption during voyage into carbon divided by ton of mass of carbon into nautical mile. To reduce this we have to reduce the fuel consumption, okay, or we have to we have to go a short distance. So in order to remove this, we have to reduce in order to decrease the CO2 emission, the fuel consumption should be the speed of the ship should be very less, and all this. Then only we can reduce the CO2 emission from a ship. So there are various management plans. The ship operator basically design the ship according to the ship energy efficient management plan. However, SCEM plans needed to be developed by the owner and implemented to potentially reduce the operational cost of ship, which will reduce fuel consumption and their emission. So how we can reduce what is there in the management plan? To use LNG fueled fuel oil system, electric motor propulsion, optimizing the speed of vessel, making a course change to tackle rough weather, hull cleaning in dry dock, heat recovery method, weather routing, rough sea to avoid, propeller upgrade and addition of flow improving device, duct and fins, etc. New lightweight construction material. These are the all waste which is included in the SMMP plan. So I have told you about regulation number 18. The fuel oil shall be blend of hydrocarbon derived from petroleum product refining. Fuel oil shall be free from inorganic acid or no chemical waste. Sulfur and NOx emission limits. So the BDN will contain date of commencement of delivery, port name and IMO number of ships, product name, metric ton, density at 15 degrees Celsius, sulfur content. BDN kept so as to ready available for inspection 3 years, retain on ship. Sample is to be sealed, signed by supplier representative and master of officer in charge. 12-month retain for MARPOL, 6-month retain on board, and local supplier 3 years retain for inspection. So this is all about annex 6 of MARPOL. Hope you have learned many things from here. So guys, if you like the video, please like and share. And if you haven't subscribed till now, please subscribe the channel to get more videos like this. Thank you. God bless.